Okay, so today we're going to be talking about when you got shapes that aren't just simple shapes that we know area formulas for. And a lot of times, the best technique for finding the area of a more complex shape is to add up the various shapes that form the overall figure. And sometimes it involves subtraction if you're cutting out different pieces. But in this case, we're going to be adding for the first two questions. So the first one is composed of um, a trapezoid with a half of a circle. So to find the area of a trapezoid, you take the two bases that are parallel. So you take 20 and add it to 32. You would multiply that by the height, which is 14, and then divide it by 2. If you use your calculator to do that, you're going to get 364 for that area. And that's going to be millimeters squared. The next thing is you're going to be taking a half circle. And so you're like, oh, I don't know how to find a half circle. Well, a semicircle, you could use the formula that you that we learned yesterday to find the area of a sector, but that's primarily most helpful if you have a weird fraction of a circle that you're trying to find the area of. And in this case, truthfully, just finding the area and then dividing it by 2 will actually work great. And so let's take the radius squared. So if you do 10 squared and you times it by pi, that'll give you 314. And so you're going to add that to 364. And we will get 678. Okay. And I should have a decimal on here. So let's see if I can do that real quick. 10 squared plus times, sorry. And then the pi key. That's 314.1 or 2. Okay. And so 314.2, and you're going to add that to 364. And that gives us 678 point, and that's 2, and that's millimeters squared. So adding those two figures together is going to give us our area. On step 2, we're going to be saying, well, what does this made up of? It's made of lots of different shapes, lots of triangles. And so, however, I think the best way is to say, you know what? The quickest way is to say this is going to be a parallelogram here. So let's do base times height. In some of my classes today, I had students do multiple triangles added together. And that works as well. As long as you do true math, you should be fine. And so this question, if you do base times height, you might need to turn the shape. You're going to do the base, which is 8 times the height, which is 5. And you're going to get this area to be 40 feet squared. And then you're going to plus that to the area of the triangle. Now, triangles, there's different kinds of triangles, but every single triangle you see, it's really just the base times the height. If you've got a right triangle, you do the base and the height. They must be perpendicular. In this case, the base is 10, the height is 5. You multiply them and then divide by 2. And so if you do 5 times 10 is 50, divide by 2 is 25. Your answer is going to be 65, and that's feet squared. So if we look to find the area of that composite shape, then we're going to get 65 feet squared. Okay, let's look at our next shape. In our next shape, notice it's a triangle missing a little chunk. So it looks like somebody took a chunk out of it. Okay, and the subtraction piece would be to subtract out a half of a circle. Okay, that kind of invaded the shape. And so again, this is a triangle, and we do base and height and divide it by 2. Well, the base and the height are the legs. You're allowed to do base and height of legs of a right triangle. And so you can do 26, all right, pardon me. 26 times 18 and then divide it by 2, and that'll be the area of the triangle. 26 times 18 and then divided by 2 gives us 234, and then we're going to subtract from that the area of the circle. Well, this circle right here has a radius of 4.5, and so you're going to do 4.5, and we're going to square it, and then we're going to times it by pi, and then we should divide it by 2. Why? Well, because it's half of a circle. So let's figure out what that number would be. If you do 4.5 squared times it by pi, and then divide it by 2, I get 31.8, okay? So minus 31.8, and so you get 234 minus that value. It gives us 202.2. Well, twos. And then that's going to be feet squared. Okay, so that'll be the area of just the shaded figure there. The next one is going to be, what is a shaded figure? Well, the shaded figure is basically a donut-looking shape. And so if you find the area of the biggest circle and the area of the smallest circle, you're going to be left with the shape between the two. So if you take the big one minus the small one, subtract out, get rid of the middle one, you're going to have the shape left that's between them. And so the area of the bigger circle is 7 squared times pi. If you subtract from it 5 squared times pi, you're going to get your answer. So let me try this. 7 squared times pi. I got 153.9. And if I subtract from it 25 times pi, 5 squared is 25. My final answer is going to be 75.4, and that's going to be inches squared. If you want to know what I got with 5 squared, it would be 25 pi. That's going to be 78.5. And subtracted, they give you this right here. So again, adding, subtracting composite figures is a valid way to find the answer for the area of weird shapes. The next one's kind of cute. If you plot these points, you're going to get a figure, and then we can find the area between it. So we've got 0, 0. We've got 0, -3. We have 3, or 4, -3, pardon me. And then we have, let's see, 4, 0, 6, 3. Okay, 6, 3, 4, 5. Okay. And then what else do we have? 2, 3. Okay. If you connect these figures, connect the dots together to form a figure. How about that? Okay. And so you notice we got a couple shapes. One way to divide them up is to a rectangle, a parallelogram, and a triangle. This right here is a 4x3. So this is 12. This is base times height. It's a parallelogram. So this is 4. This is 3. That also is 12. And this right here is 4. And this is 2. So you do 4 times 2 and divide by 2. You get 8 over 2. This area is 4. So if you add 4 with 12, 12 again. Again, the triangle is the base times the height, which is 4 times 2, which is 8, and then divide by 2 is going to be 4. You're going to get 28 units squared. So find an area. Okay, on your homework, there's going to be several where you have to do the Pythagorean theorem to find missing sides, or you're going to have to do special right triangles to say, hey, it's a 60-degree angle. What's that mean? Can I find those missing parts? There's a 30-degree or a 45-degree angle. Can you find the missing sides so you can find the perimeter or the area as appropriate for those questions? Okay, so our next side is going to talk about geometric probability. And probability in general is how likely something is to occur. You want to put what you want out of the total. And so in geometry, you're like, how would you do that in geometry? Well, I think the big thing would be, we could talk about, say that you want to, it's what you want out of the total. Okay, so what you want, I should make a pen, what you want out of the total. What do you mean? Well, if you're going to roll a dice, say you want to get a 2. Okay, there's one way out of the 6 ways to roll a 2 on a die. Another thing would be, say that you're looking at a segment, and every segment has infinitely many points on it. So what's the probability that you pick a point between any two letters? Well, you have to know the length of that segment. Okay, so say it's like 5. We'll say that the whole length right here is going to be 12. Well, the probability that you pick it between B and C would be 5 out of 12. Where you want to be compared to the total. And so same with this, if you had a spinner, like you're playing a little kid's game or something, and you're like, hey, I want to spin in that blue section. Well, you have to say, how many degrees is that out of the total? So say this is like 40 degrees. You would put 40 out of the total. Well, the total of degrees is 360 degrees. Okay. The next thing is, same with area. Okay, so you're going to throw a dart, a dartboard, and you're like, what's the probability that you hit this bullseye? Well, it's really small, and so it's not a very good for probability, but what you do for a shape would be you find the area of the shape you'd like to land in. So it'd be like the area of the triangle over the total area. So your goal compared to the total. So you can look at the stuff on the left and see kind of those goals. Okay, so moving forward, we're wondering if we can find the probability that if you choose a point or place a point on that segment below at any point, where would it, like, what would be the probability that you would place it between R and S? Well, the way you figure this out is you would say, well, how big is RS? Well, it's 5. And how big is the overall shape? And you place that probability of where you'd like it to land and place it over the size of the entire shape. So that would be 25. Now, probability can be written as a fraction, and you'd reduce it, or as a decimal, or as a percent. And this says, please put it in percent. So if they said leave it in fraction, you'd reduce it. You divide 5 divided by 25. You get 0.2. Change it to percent by times it by 100. That's 20%. So the probability that if you place a point on this segment, is that it's between R and S is a 20% chance. Good question. What if it is not on QR? Well, QR is going to be this 13 thing. So if you don't want it there, well, then where would you like it? Again, the probability is where you'd like it over the total. And so I would like it either between here or here. So it'd be 12 out of the 25 entire length. Again, reduce it if you could. If they're going to leave it as a fraction, this doesn't reduce. To get it into decimal form or percent form, you divide 12 divided by 25. And you're going to get 48%. 0.48 is what you get with a decimal form, times it by 100. The last one says, what is the probability that that point is on PQ or on QR? Okay, so these two on the left. Well, the length of that segment that we're wanting it to go to is 20 over the entire length, which is 25. So it's what you want out of the total. You could reduce it if you leave it in fraction form, or you, in this case, ask you to divide it. 20 divided by 25 is 0.8, which is 80%. So there's an 80% shot that you're going to get it in those two segments. And so the next thing is like spinners. And I've seen something like this on the ACT recently. I was working problems with somebody, and they're like, what's the probability that it would land in this segment? And what you've got to do is figure out the area of that segment, or what fraction of the total that segment is. Well, this is asking, what's the probability that it's on yellow? Well, yellow, we don't really have to figure out an area. We can just say, well, the area that is covered is 140 degrees out of the total, which is 360. As long as you can represent the spot that you want out of the total, you're going to be good. And that says put it in a fraction. So you can take 140 over 360, and you want to reduce it. If you reduce 140 over 360, you divide them both by 10, and then you can divide by 2. So dividing by 20 will help you. You get 7/18. So 7 out of 18 is going to be our reduced fraction form. If you want it to either be on blue or red, you can add up those two good segments because you're good with either one of them. So you do 60 plus 52 and put that over 360. So 112 is the degrees that we're looking for out of 360. And then let's reduce it. And what I get is 14 out of 45. Okay, and so go ahead and reduce fractions if that's what they want you to leave it in. The last one says, what is the probability of it not landing on green? Well, green represents 108 degrees of the shape. And so you're like, well, I don't want it on green. So anything but green. Well, the easiest way to figure out what the other ones are would be to either add them up or subtract 108 from 360. So I'm going to take 360 minus 108. Say, okay, well, 252 degrees are actually good. And so you do 252 out of 360. If you reduce that, you're going to get 7/10. If you divide it, you get 70%. So there's a really good shot that you won't get green if that's what you're hoping. Even if you aren't hoping, there's a pretty good shot that you won't get green. So the last topic is going to be area probability. Again, we're saying, if you are going to land in this room or land in this rectangle, what is the probability that you will land in the circle? Okay, so you're like pair jumping into there or something like that. So the question is, what would be that? So you do the probability or the area of the circle over the total area. Well, the area of the circle is radius squared times pi, so it would be 9 squared times pi. You put that over the total area, which is a rectangle, which would be 50 times 28. Okay, so if you do 9 squared times pi, you get 254.46. If you divide that by, it's about 254. There's decimals after it, 0.47 over 50 times 28. 50 times 28, okay. Is going to be 1,400. If you use those two numbers, you get 0.1817. So 18%. Oh, it doesn't say for percent. Okay, 18% or 0.18. So it's not very likely you'll land in the circle, but it's not impossible for sure. There is a spot for you to land, and it's not terrible. It's almost 20%. What about the trapezoid? Well, let's take the area of the trapezoid, excuse me, and place that over the total area. To find the area of the trapezoid, you have to take the sum of the bases. The parallel bases of the trapezoid are 34 plus 16. You times it by the height of the trapezoid, which is 18. You divide that by 2, and if you figure out that answer, you get 450. Excuse me, sorry about that. Cold. And so then over the total area, which is 1,400. They don't say reduce it, they say divide it. So 450 divided by 1,400 gives you 0.32. Okay, and I'm rounding that off. So I think the big thing is, can you find the area of the spot you're wanting and put it over the total? The next one says, what's the probability that you will not land in the triangle? Well, the easiest way to figure out that is to say, well, what's the total? And the total of the shape is going to be the area. So 18 times 24, that's 432. And so you don't want to land in the triangle. Okay, so you want the area of everybody else. Okay, so everybody else, when you exclude the triangle, well, we can take the total and subtract out the triangle. Well, the triangle's area is 1/2 times base times height. So it'd be 12 times 18, and then divide your answer by 2. The area of the triangle is actually 108. I'm going to write that right in the triangle, 108. Okay, so if you take 432 minus 108, you're going to get this area all outside of here. And be like, okay, we're hoping to land not in the triangle, just outside of it. And so that's going to be 432 minus 108. You get 324. If you divide those, it doesn't say how you want to do it, so you get to choose. You can reduce it, you can divide it, you can get a percent. Let's get a percent. So let's divide 324 by 432, and we're going to get 0.75 or 75% chance. And notice that's a pretty good shot. Plus, like most of the place is not even in the triangle, so that makes sense. Okay, the next one says, what's the probability that you'll land in the square? Well, the area of the square is 49. Okay, base times height, 7 by 7. This is the square. Okay, out of the total, which is 432. Okay, divide those again. 49 divided by 432, and you get 11% chance. Not a great shot, but that's a smaller spot to land in. Okay, the last one says, hey, assume that you're going to land somewhere in the rectangle. So assuming you're not going to miss. Okay, assuming you're 100% shot, you're going to land on the rectangle. What's the probability that you'll land in the circle? Okay, well, all right, probability of the circle is radius squared times pi. So 9 times pi, radius squared is 9. And then over 432, what is that probability? Pi equals, and divide it by 432. That is 7%. I got 0.065, so that would be 7% shot. So today what we talked about is how can you get figures, like the area of complex figures? Well, you add up or subtract out pieces of shapes to be able to get the area that you're looking for. Okay, the other thing we're looking for is, can you do probability? Okay, locationally speaking, we're talking about what you want over the total place for it to be. And so the total shape is going to be on the bottom. The probability is going to be that division of what you'd like over the total options. All right, have a good day.